Hello everyone. Today we will start talking about the nose, which is the first part of the respiratory tract. What are the functions of the nose other than giving some beautification to our facial features? Number one, it provides an airway for the respiration. It conditions the inspired air. In combination with the paranasal sinuses, it provides resonance to our voice. And last but not the least, it houses the olfactory epithelium for smell. Knowing after all these vital functions of the nose, we have to look at the nose itself. I'm holding in my hand a skull model, a human skull model, and you can see here is the nose, which is the most prominent feature. We can easily figure it out, okay? And you can see, like from the side base, you can see it. It's like a complete nose, which is rare to be found in a dried skull. Why? Because I have made the anterior two-thirds of the nose with the help of some clay. This blue colored portion of the anterior two-thirds of nose is the hyaline cartilage, which is making the lateral walls and the central septum of the nose, just the anterior two-thirds. Okay? The posterior one-third of the nose and the septum are bony. Alright, what it is doing, the anterior two-thirds, the cartilaginous portion of the nose, is giving beauty to the face. And also, if I try to narrow down my nostrils when I'm inspiring very deep, I can do it because of this flexible cartilage. If I am exposed to some bad odor, I can pinch my nostrils. I can pinch over my cartilages and I will close the two nostrils. Okay, which I can't do if I hold my nose and pinch it from the top, from the root. Okay, because it's all bony. Alright, we will talk about the septum in detail some other time, and let me show you the actual nose. By the way, just before the removal of the clay, you just have a look at how these nostrils, the anterior and the right and the left anterior nostrils or anterior nares are narrow, and in between is the cartilage septum. Okay, now I'm removing the anterior two-thirds altogether. Here you can see how big the anterior nares or the nostrils are without cartilage, lateral cartilage walls and the central septum. We do have a septum which is now bony. It's dividing the entire pyramidal shaped single nasal cavity into two halves, a right and a left. Alright? When we have the anterior nares or the anterior nostrils, we must have the posterior nares. Okay? So if I'm flipping the skull upside down and I'm showing it to you from behind. So you can see here is the anterior, like the nose is upside down and the anterior nares are here, and I'm inserting a probe through one of the anterior nares and it will be passing through the posterior nares on both sides, as you can see. This is where, at the posterior nares, the nasopharynx part of the pharynx is residing. And it's, the air enters through the anterior nares and passes backward towards the nasopharynx. We'll talk about the nasopharynx along with the pharynx and larynx. Okay? Let's talk about the bony architecture, the external architecture of the nose. Here in front of you is the model with the cartilages have been removed. Okay, and you can see through the anterior nares, which are now much bigger. They are oval, window-like structures, and in the center is the nasal septum, the bony part of the septum, and you can see the lateral walls, the bony lateral walls are showing scroll-like elevations. Okay, these scrolls, anatomically, we call them concha. Concha is a single, and then conchae if there are multiple. So we have 3 conchae on each lateral nasal wall. But in the clinical terms, we call them turbinates. Why? I'm going to tell you in a few minutes. Okay? Now first have a look at the bony architecture, the external bony architecture of the nose. So the top part, or the dorsum of the bony nose, has been formed by these 2 flat plates of bone, which are the actual nasal bones. Okay? And the nasal bones, they are joined with each other by an internasal suture. And they are also joined by the frontal bone on top by a transversely running suture. The suture is known as the frontonasal suture. On the sides, if you look at the lateral wall of the nose, you can see another suture, which is completing the lateral wall. The suture between the nasal bone and the nasal process of maxilla. This bone, the cheekbone, is known as the maxilla. It sends a process, a finger-like projection, which is meeting the nasal bone and is forming the lateral bony wall. This is known as the nasomaxillary suture. Okay? This process, by the way, it has been mentioned in some of the books as the frontal process of maxilla, as it is heading towards the frontal bone. Okay. Then, so we have the 2 lateral bony walls and the central dorsum. All right. Now you can see one thing, that the floor of the nose is being formed by this bone, a plate from this bone. So we have a right maxilla and a left maxilla, and then they send flat processes inside that the 2 processes will form the hard palate. You can't observe the hard palate from this view. So first I have to flip the skull and show you the inferior part. Okay, so you can see over here, this is the mandible, by the way, and this is the hard palate. This is the hard palate. That is the combination of the palatine processes of maxilla, and then there is another bone at the back, which is an L-shaped bone. It's sending a horizontal process on each side. It's again a paired bone, just like maxilla. The palatine bone is making the posterior 1/3 of the hard palate. Okay, so now come back to our normal position and I'll show you. All right, so this is the back of the nose. The posterior nares are visible, and I'm entering a probe through the anterior nares, and it is entering, it is coming out, it is visible through the posterior nares. Okay, now you can see that the hard palate, which is this structure, it's making the floor of the nasal cavity above and the roof of the oral cavity below. This is the oral cavity, which has been surrounded by the teeth, and the tongue is missing because it's a hard specimen. Okay? All right. So, come back to the front. Here is our nasal pyramid, and we are looking at the turbinates or the conchae, and I'll be talking about these conchae in just a few minutes. Before that, I also have to talk about a bone which is not exactly visible from outside, but a part of it is visible from outside. That is this part. This is the perpendicular plate of the ethmoid bone, which is present in the center. It's an unpaired bone present in the middle of the cranial cavity, and it is dividing, or it's actually separating the nasal cavity from the anterior cranial fossa inside. Okay, so here you can see this ethmoid bone is sending a straight bony spur, which is known as the perpendicular plate of ethmoid bone, and it is making the anterior portion of the bony septum. At the back, this bone, again it's the bony septum, but it is not the perpendicular plate of the ethmoid bone which is making this part. It's the vomer bone. It's a mass-shaped bone which is there to complete the bony part of the internasal septum. Okay? The back part of the internasal septum. I hope that you have understood this concept. Now we have to look for the other parts of the ethmoid bone. It's an unpaired bone, but it has multiple parts, and I have a good drawing of ethmoid bone, because I cannot take out the entire ethmoid bone. It will disturb the entire architecture of the face and the cranium. All I can say is you have to focus on the medial walls of the orbit. So this is the orbit, the lateral wall, and the medial wall. So you can see the medial walls of the orbits on both sides. They are formed by the labyrinth of the ethmoid bone. These are the flat plates of ethmoid bone, which are spongy from inside, and they are actually having big air cells, air-filled spaces, known as the ethmoidal air sinuses. We have a bunch of paranasal sinuses. One of these sinuses is the ethmoid sinus. Okay, so a bony labyrinth is making the medial wall of the orbit on the right side and on the left side. The root of the nose, or the roof of the nose, which is also known as nasion, if I insert my probe up, I will actually be entering into the anterior cranial fossa. Okay, so I have removed the skull cap, and you are looking inside the cranial cavity, and you can see there are shallow depressions. The anterior cranial fossa, the middle cranial fossa, the posterior cranial fossa. All these fossae and the details of these fossae will be discussed in the lectures of brain and cranial cavity. But at this moment, we have our focus over this bone, which is like, it's black over here. Actually, it's an artifact. But you can see here, these are the two cribriform plates of ethmoid bone. I hope that you're able to see these tiny holes. These tiny holes are for the passage of olfactory nerve fibers, because on either side of each cribriform plate of ethmoid bone is resting or residing the olfactory bulb, which is the organ of smell. So we have a pair of olfactory bulbs resting upon the cribriform plate of ethmoid bone, and they are sending their extensions into the root or the roof of the nose for capturing the odorous molecules. Okay, now we will come, like we are done with the hard part of the bone, or the osteology of the bone. We will discuss its lateral wall and the bony elements in detail on the board drawings. Okay? All right. So here we are with our board drawings. Before moving on to the lateral wall configuration and everything regarding the epithelium and other stuff, I have to mention the architecture of the ethmoid bone, which is a very complicated but extremely important bone of the cranial cavity, and it was also participating in the formation of some of the facial skeleton also. So I just gave you the description how it has been placed in the center of our face and the cranium. It's in between, okay? And I also mentioned that it has the two labyrinths, like flat plates. One is making, like the right plate is making the medial wall of the right orbit, and the left plate is making the medial wall of the left orbit, okay? And then there is a perpendicular plate which is visible from inside the nasal cavity, just making the anterior portion of the intranasal bony septum, okay? Then we have something which is inside which is not visible from outside, but it is visible from inside the cranial cavity within the anterior cranial fossa. In the floor, we have observed the cribriform plates, part of the ethmoid bone, which are allowing the passage of fine thread-like olfactory nerves, and those nerves are entering the root or the roof of the nose. Okay? Now, keeping all this concept in your mind, focus on the drawing which is visible on the board here. Forget about all these, we'll discuss one by one. This is like an ethmoid bone taken out of the cranial cavity or cranial framework. Okay? It pretty much looks like a war tank. Okay? With like it's like a stout bone, pretty much irregular in shape. It has the top part which is present inside the cranial cavity in the floor of the anterior cranial fossa. So these are the two cribriform plates of ethmoid bone. And I forgot to mention, I actually haven't mentioned one of its processes. The one which is visible from inside the nasal cavity is the perpendicular plate, while there is another process which you can observe within the cranial cavity, anterior cranial fossa. It's a tooth-like process which is known as the Crista Galli. Okay, so if I draw this process, like this perpendicular plate of ethmoid bone is extending inside the cranial cavity and it's giving rise to this tooth-like process. Okay, we will be doing much detail of this Crista Galli when we will be talking about the attachment of the meninges, the dura mater. Okay, so this is not our topic for today. On either side of the Crista Galli, we have the cribriform plates of ethmoid bone, and you can observe the fine holes in the cribriform plate. From here, there is the descent of the perpendicular plate of ethmoid bone, which is present in the middle of the nose. On either side, we have the two plates of ethmoid bone, which are known as the ethmoid labyrinths. These are the ones which are making the medial walls of each orbit. Okay, and you can see these air-filled spaces. These are known as ethmoidal air cells, and they have been grouped in three separate groups. Like they have been classified as three separate groups, and I'll be discussing them very shortly. Okay, so this is the architecture of the ethmoid bone. This is the cribriform plate, the Crista Galli, the ethmoidal labyrinth, which is a part of the medial wall of orbit on each side, and this one is nothing but our perpendicular plate. Okay? Okay. Alright. Now, I would like to remove this picture, as I'm assuming that you have understood the architecture of a very difficult bone. Okay? Now, after removing the ethmoid bone, which is making the center of our nasal cavity, and it's a communication, like it's communicating through the cribriform plate, communicating the nasal cavity with the anterior cranial fossa. Okay? Alright. Now we'll move on to the next drawing. Here is if I cut section, like if I take a sagittal section through the skull, and I am looking and I have removed the septum, the central part, and I'm trying to look at the lateral wall of the nose from inside. So this is the inner or medial view of the lateral wall of the nose, minus the septum. Okay? Keep that fact in mind. Now look at this. these are which I just mentioned in the beginning, these are known as the conchae or the turbinates. These are like, if I have this felt, it's something like this. Like this. Sorry. Okay? So it's one piece of bone. Paper thin bone. Keep in mind, most of the bones of the face and cranium, especially the viscerocranium, are paper thin. They are easily fracturable bones. So it's as if it's a single bone. And you remember our ethmoid bone labyrinth, which was making the medial wall of the orbit, and it was also participating in the formation of the lateral wall, inside lateral wall of the nose. Okay, so here is the position of the ethmoid bone, and you can see these are the two scrolls. So this is the ethmoid labyrinth. This part of the labyrinth has been placed like this. Okay, try to picture. So this flat part is making the medial wall of my orbit. Okay, while its bumpy part, the part which looks like scrolls, is making the lateral wall of my nose from inside. Okay, so we can say that the superior and the middle conchae or turbinates are nothing but the part of the bony ethmoidal labyrinth. They are the part of ethmoid bone. Okay? While the third scroll itself is an independent paired bone, the inferior concha. It's a paired facial bone which is present on either side of the inner part or the medial aspect of the nose, lateral wall of the nose. Okay? So the superior and the middle conchae are the part of the ethmoidal labyrinth or the ethmoid bone. The inferior concha is a separate independent bone. It's a paired bone, one on the right side, the other on the left side, and it is sitting on top of the maxilla. Okay? Now, why do we call them turbinates? So, now you imagine that the entire lateral nasal wall has been covered by mucosa. Okay? The mucosa is this like felt-like lining. It's having epithelium, it is having lamina propria, it is having a lot of seromucous glands in the submucosa, right? So it's having muscularis mucosae, all the elements of any histological layer. Okay? So the nasal mucosa is like a felt, and it is covering every aspect of the lateral nasal wall as well as the septum of the nose. Okay? But here you can see a distinction. Yeah? It's like between, there is a color coding. You can see over here, before that, let's have a look at this. This is the frontal bone, this part of my forehead. This is the root of the nose. The frontal bone is hollow at different points. It's having the frontal sinus, air-filled spaces. Okay? Then we have just behind, we have the anterior cranial fossa, and we have the ethmoid bone, which is having these gaps in the form of cribriform plate. Then at the back, we have the sphenoid bone, a bone which is like you haven't heard of it in this lecture. The sphenoid bone is again an unpaired, centrally located bone, which is lying just behind the ethmoid bone. Okay, so the sphenoid bone is pretty much strong, and it is like it's again an irregular type of bone, and we will discuss the details and anatomical details of the bone along with the cranial cavity, cranial bones, and the brain lectures. Okay? Alright, for now, all our concern is with this hollow space which is located within the sphenoid bone. Specifically, the body of the sphenoid bone is hollow from the inside, just like any other facial bone, like maxilla, frontal, ethmoidal. Here is the sinus which is present inside the sphenoid bone. It's known as the sphenoidal air sinus, one of the paranasal sinuses. Okay? Now we'll come back to the lining of our lateral nasal wall. Okay? And why do we call these conchae turbinates? So imagine that we inhale air from our nostrils. Through the nostrils, I have inhaled air, and it is passing up from by the way, this area of the nose, which is like we can see if we try to look under our nose, inside the mirror, we can see an area which is having like a big collection of coarse, short hair, which are known as vibrissae. This area is like a dilated, expanded area. Okay? So any dilated area it can be known as vestibule. Okay? So here is the vestibule of nose. Vestibule of nose. Okay? So the air entered through the vestibule of nose, and then it cannot be transmitted immediately down through the nasopharynx into the larynx and through the tracheobronchial tree. It needs a lot of conditioning, as we just discussed many times. So and also you have to keep in mind, in air we have suspended odor molecules as well. The molecules of smell, good smell, bad smell, perfumes, food, many things. Okay? So for air to stay inside the nasal cavity, it needs a large surface area. Okay? That's why those bony scrolls were present in the ethmoid bone as well as in the inferior concha. And these bony scrolls are covered by a thick nasal mucosa, and that nasal mucosa is just, wrapping around each scroll. Okay? So when the air entered, it just received a lot of turbulence. Okay? It faced a lot of turbulence. So the speed of air got slowed down. That's the requirement of my body. Okay? Because I want this air to stay in my nose, in my nasal cavity for longer time, so that my olfactory epithelium would be able to absorb or receive the odor molecules, the sense of smell. My respiratory mucosa would be able to condition the air by cleansing the larger particles that will be trapped inside this vestibular coarse hair, which are known as nothing but vibrissae. Okay? These are fine, they're coarse, short hair. They will be trapping larger particles of dust and pollution within them. Okay? And then the air will travel further higher up into the cavity of the nose, where it will face turbulence, and because of the covering of the conchae, the surface area for absorption and contact will be increased, right? The mucosal surface area will be increased, and we know that the nasal mucosa is having a lot of secretory glands. They are constantly producing seromucus secretions, and they will be helping, further clarifying the air from fine particles, dust, organisms, and other stuff, and also the mucus will give some moisture, will add some moisture to the dry air. Okay, so that's why clinically these conchae can also be known as turbinates. Okay, we have discussed that the superior and the middle turbinates are the part of ethmoid bone. There is something which is lying above this space. This is the superior concha, and here is this space. The space is between the superior concha is a part of the ethmoid bone, and this is the sphenoid bone. So high up, close to the root of my nose, I have a space on either side, a recess, that is known as the sphenoethmoidal recess. Why? Because this is the sphenoid bone. And the space lying between the ethmoid and the sphenoid is known as the sphenoethmoidal recess. There is something which is opening into the sphenoethmoidal recess. We have two, right and left. Okay, keep in mind. Then we have, just look at this color coding in mucosa. Okay, now look at this. The green color is representing the mucosal lining of the vestibule of nose, the first part, the antemost part, dilated part of the nose. That is lined by a specific epithelium which is, special for the skin. We have this special epithelium of stratified nature which is lining the skin of our entire body, and regions which need much more protection, right? So this is the epithelium of the vestibule, and we can see that it is showing a stratification. So this is the stratified squamous, because the top cells are flat. Stratified squamous epithelium. Okay, so that is the epithelium of the vestibule, this green thing. Okay, I should have used the green color. Then the 2/3 of the nasal mucosa, the lateral wall as well as the septum in the middle, is covered by a typical respiratory mucosa, which we just discussed in the previous slide. It's of which type? The pseudo-stratified ciliated columnar epithelium, which is lining all these conchae. Okay, so pseudo-stratified columnar ciliated. Cilia are playing a pivotal role. Ciliated columnar epithelium. They are lining the 2/3 of the lateral nasal wall and the middle septum. It's the typical respiratory epithelium. Okay, that would be doing what? It would be conditioning the air, processing the particle entrapment, adding mucus to the air, and other functions. Okay, then at the very top, over the superior concha, just above the superior concha, and partly the superior concha is also covered, like here, up till here. They say that this area is of the size of one's thumbnail. Okay, slightly bigger than a thumb's nail. Okay, this area is present on the superior conchae, the sphenoethmoidal recess, and it's like U-shaped area. Okay, and you know that what is lying above this nasion is the cribriform plates of ethmoid bone. Okay, and we have the olfactory bulbs lying on top of those cribriform plates. So this area, or the mucosa, is known as the olfactory mucosa. So the olfactory mucosa is lining the superior concha and the sphenoethmoidal recess. Okay, if you examine the nose, the nasal cavity in a clinic, with the help of torch, you would be able to observe that in general the nasal mucosa appears like pinkish red, okay? Except for the vestibule, because the vestibule is covered by coarse black colored vibrissae, okay? But if you go up, the conchae in general are lined by the pseudostratified ciliated columnar epithelium, which is pretty much pink red. But in contrast, when you reach high up to the level of the root or the roof of the nose, you will see that there would be an instant change, a very, very remarkable change in the color of the mucosa. That is like the mucosa in that region, it appears yellowish, it's pale as compared to the rest of the mucosa because of the presence of these neuronal cell bodies. Like over here, you can see these are the bipolar neurons which are occupying, populating the superior concha region, and they are making the olfactory epithelium. The olfactory epithelium is not that much richly supplied by blood, while the pseudostratified ciliated columnar epithelium, as we have discussed, that the nasal mucosa needs a lot of blood circulation for the warming up of the inhaled air, okay? Temperature monitoring. This is not the case with the olfactory mucosa, okay? We will discuss these bipolar neurons of the olfactory mucosa in detail when we'll be talking about the first pair of cranial nerves, that is the olfactory nerves, okay? All right, so the vestibule, antemost, then the conchae, and in the topmost area is the sphenoethmoidal recess, which is lying above the superior concha, okay? Now we are also able to see few red colored openings, you know, as I just have told you that the superior concha is having the superior meatus lying under it, as I was mentioning that the conchae or the turbinates are like scrolls, and they are hovering over the openings, and they're like trying to hide the openings under them, okay? And these openings are meatai, so under the shadow or under the cover of superior concha, we have the superior meatus that receives the opening of the posterior group of ethmoidal air cells. So I hope that you are able to recall that I said that the ethmoidal labyrinth is a collection of air-filled sinuses. These air-filled cells or sinuses, they are arranged in three groups. The posterior, which is back towards the cranial cavity, then the middle, and then anterior. All right. So the posterior, the posteriormost group of air cells will drain into the superior meatus here. Okay. Then we come to the middle meatus, where I mentioned that too many things are opening, there is a lot of traffic in the middle meatus. So what we have done over here, we have taken out the middle meatus, right? And I have, you know, magnified it. And you can see there are 1, 2, 3, and 4 openings, all right? But before going on towards the openings, I have to mention something that, excuse me, as you can see, this is the superior concha, and under the cover, middle concha, and under the cover of middle concha, there are few structures, like some bulges are there, okay? So this bulge, as a matter of fact, is because it has been produced by the ethmoidal labyrinth, like it's bulging into, so we have the ethmoidal labyrinth here, and it's bulging into the lateral wall of the nose. As I also have told you that the superior and the middle conchae are nothing but the scrolls hanging down or coming out of the ethmoidal labyrinth. They are the part of the ethmoid bone, okay? So this bulge, which is present within the middle meatus, is known as the bulla ethmoidalis. You can also call it ethmoidal bulla. Okay, it's like a bulbous structure. Bulla ethmoidalis. And then there is something which is like a hiatus, like a crescent-shaped opening, all right, a furrow, hiatus. So we call it hiatus semilunaris because it looks like a half moon, a crescent. Semilunaris. All right, so this is hiatus semilunaris and this bulge is the bulla ethmoidalis. Okay, now we can see the four openings. We are done with the posterior group of ethmoidal air cells. Now, in the bulla ethmoidalis, the middle group of ethmoidal air cells will be opening. Okay, then in the hiatus, just anterior, because this is anterior, okay? The anterior-most structure which will be opening at the summit of the hiatus semilunaris would be the frontal sinus. Alright? It's opening into the very beginning part of the hiatus semilunaris. Okay? Then we have, just behind the opening of the frontal sinus, we have the anterior ethmoidal group of cells opening. Okay? So the anterior ethmoidal cells will open in the hiatus semilunaris, again in the anterior part of the hiatus semilunaris. In the middle, or the rather a little bit back, like posteriorly, the hiatus semilunaris will receive the last but not the least sinus, that the opening of that sinus, the maxillary sinus. Alright? We can see the maxillary sinus, the antrum of the maxillary sinus is slightly below the level of the middle meatus, right? So it will be opening in the hiatus, the back part of the hiatus semilunaris, and will be moving towards the, like against the gravity, okay? The drainage from the maxillary sinuses will always be against the gravity, okay? All right. Then we are left with something which is the inferior meatus. The inferior meatus is receiving one duct, that is the nasolacrimal duct. The opening of the nasolacrimal duct is here under the cover of inferior concha or inferior turbinate. Alright, and we know that the nasolacrimal duct is collecting the tears which are produced by the lacrimal gland, right? And then it's draining into the inferior meatus, alright, connecting the orbital cavity with the nasal cavity. Alright. So, we know that the entire mucosa of these sinuses is similar as of the mucosa of the nasal cavity. It's lined by the pseudostratified ciliated columnar epithelium. The cilia are, the cells are producing copious amount of mucus all the time, and the cilia are moving that mucus towards the nasal cavity. I'm talking about the paranasal sinuses. They are moving the mucus, the cilia of the paranasal sinuses are moving the mucus towards the nasal cavity, and from the nasal cavity sometimes we get a lot of discharge in case of common flu or rhinitis or sinusitis. And what is happening inside the nasal cavity, the mucosa or the cilia of the nasal mucosa, they are moving in the backward direction towards the nasopharynx. From the nasopharynx, the mucus which has been produced and released by the glands, the goblet cells present in the nasal mucosa, that mucus, the film of mucus, will be drained into the nasopharynx. Through the nasopharynx, it will go down to the pharynx proper and then to the stomach, okay? So we are constantly gulping over our nasal mucus, all right?